Okay, make sure you have a pen and paper ready to make notes. Use the benefit of video. You can always rewind to repeat things if needed. Be prepared to pause. Occasionally I will suggest you pause to read something or complete an activity. If I do, make sure you do that. Real learning comes from active participation, not passive listening. I'm going to start today as usual with 4 questions. Give these a go. Don't give yourself any more than 4 minutes at most to try these. We'll pause it for the answers. Okay, the answers on these are on screen now. For this one, I took away 3 and then I divided by 2 to get x is 2. This one, I started by expanding the brackets. 5 times 3x, 15x. 5 times minus 4 is minus 20. Expand the brackets. You can either do that using foil, dodgy eyebrows, or a grid. Either way, you should have these 4 components. The middle part, plus 3, take 4, give you the minus 1x in the new simplified expression. And the final one, we're factorizing, so we need 2 numbers that multiply to give 7, but add to give 8. Now 7 is a very handy number to have because it's prime, which means the only factors of 7 are 1 and 7, which does limit the options on that question. Okay, today we are going to be looking at solving equations where we have an unknown on both sides. So you'll have x on both sides of an equation. Okay, so here are 2 examples. Just so you know, I've tried to use as many different letters as I can to make it so we're not always using the letter x, because although it is very common, it is not the only letter. On the first one, I have 8k plus 5 on one side and 7k plus 17 on the other. And what we know is that on each side of the equation, the expression is worth the same. So 8k plus 5 is worth the same as 7k plus 17. It is that fact that we're using in order to find k. The first thing I'm going to do is subtract 7k. The reason I'm subtracting 7k is because if I do that, this 7k here will disappear. And I'm left with k plus 5 is 17, which is much easier to solve. If I have k plus 5 is 17, my next step is to subtract 5 from both sides, which will give me 12. Just notice there's no 7 there. There we go. On the next one, I have 3a plus 18 is the same as 5a plus 8. I'm going to start by subtracting the 3a. So to get rid of a positive 3a, I'm going to subtract 3a. I'm doing the opposite, just like you would have done when you were solving equations, more like the second line, like this. The 3a has disappeared, and 5a take 3a is 2a. Notice that the numbers aren't changing in that first step, okay? So don't change the numbers in the first step. You start by subtracting a letter. Then I'm going to subtract a number. I've got 18, 2a, and 8. I'm going to subtract 8 so that plus 8 disappears, leaving me with 10 is 2a. And if 10 is worth 2 of something, then 1 of that thing must be 5. Now, there are different ways to approach this. What I would always suggest, that first step when you are subtracting one set of the letters, choose the one you have least of. I have 7k on one side, 8k on the other, so I chose to subtract 7k because it's smaller than 8k. On this one, I chose to subtract 3a because it's smaller than 5a. The reason we do this is because if you subtract the bigger one, you'll end up with lots of negatives to deal with, which none of us want to do. So it's always best to subtract the smallest value of your unknown. Okay, now that you've got those 2 examples done, on screen are 4 questions I would like you to have a go at. Always start by subtracting the smallest value of x in these cases. Pause it, have a go, and then unpause for the answers. Okay, answers are on the screen now. On this one I subtracted 4x first and then the 7. On here I subtracted 2x and then 9. On this one I subtracted 4x, then I subtracted the 15 and then I divided by 4 for my final step. Don't forget, you have to do it to both sides. This one I subtracted the 5x, then the 10, and then I divided by 2. Absolutely nothing wrong with a decimal, okay? If it comes out as a horrible decimal, you'll have to either round it or leave it as a fraction, whichever is more appropriate. Okay, unfortunately, so far every question you've done is all positive numbers, and of course we know that quite often this is not going to be the case. We're going to have a few negatives. On this one you can see I've got a negative 18. It doesn't change the first step. I'm going to get rid of my 2z by subtracting them, leaving me with this equation. To get rid of the minus 18, I'm going to do the opposite of take 18. I'm going to add 18 because that will cancel out the two number 18s, leaving me with 28 is 4z. Remember, you do need to do it on both sides. If 28 is equal to 4z, 1z must be 7. On this example, we not only have a negative number, we have a negative x as well. Now, I've said so far every time that we always get rid of the smallest value of the letter first. And a lot of people will go for the 2, but don't be fooled. Remember that minus 3 is much smaller than 2. If you had a number line, you would definitely be able to spot that minus 3 would be much lower on that number line than a 2. Okay? Because that's a positive 2. So I'm going to get rid of the minus 3 lots of x first. And to do that, I'm going to add 3x to both sides. This will cancel out the 3x, so this will go, and we'll be left with 5x minus 21 equals 9. From here on in, it's just as before. To get rid of the minus 21, I will add 21 to both sides, leaving me with 5x is 30. Divide by 5, x is 6. So on this, the only thing to note that's different is that we are getting rid of the smallest value of x still, but it's a negative 3. The negatives are obviously going to be smaller than our positive values of x. Okay, there are 3 questions now on the board. I've left that example up for you. So the orange and the green question are like the example on the board. Pause it, have a go, and then reveal the answers by unpausing. Okay, the red question. We should have subtracted 4x, added 15, and divided by 4. The second one, we should add 4x to get rid of the minus 4x, leaving me with this. Then I'm going to add 21, and then divide by 7. And the final one, again, the minus 4 is smaller than 1x. So I'm going to start by adding 4x again, subtracting 3, and dividing by 5. And here we have a fraction answer. Nothing wrong with leaving it as an improper fraction, but if you want it as a decimal, it would be 1.4. The question might also be further complicated with the inclusion of brackets. In such an example, it is nearly always best to start by expanding the bracket out. In this case, 2 times x is 2x and 2 times 7 is 14. From here, we are going to subtract the smallest value of x, leaving me with 14 is 4x plus 6. Then, subtract the 6 from both sides, leaving me with 8 is 4x. And now, to get rid of this 4, I will divide by 4, giving me that x is 2. At any time, by the way, you can always check these are right by substituting in for x and making sure both sides give you the same answer. In this case, 6 times 2 is 12, plus 6 is 18. 2 plus 7 is 9, times 2 is also 18. So that works. Here are a variety of questions. You'll have to think very carefully about the ones on the green side, but pick your difficulty, and if you want to, you can move forward, check the answers, and then carry on if you feel you need more practice. So pause it now, have a go, unpause it, and the answers will appear. Okay, answers on these are on the screen now. Once you've checked them, we can move on. Finally, I want to just show you that you can actually combine this with geometry. It's very common for algebra to be paired with geometry questions, so questions about angles and distances, and you'll need to recall a lot of common facts to solve some questions on this. Here's a typical example. Calculate the size of the largest angle from this diagram. Okay. Now to do that, we're first going to have to find out what the value of x is. Now these are what we call vertically opposite angles, and they're equal, so we know those two obtuse angles are going to have the exact same size. We can use that fact therefore to write an equation that one side, 3x plus 18, is equal to the other angle, 5x minus 47. From there on in, we would solve just as we did before. So subtracting 3x, adding 47, and dividing by 2. We've now worked out that for that diagram, x must be 32.5. We can also use that then to work out the actual size of the angles. So if it said calculate the size of the largest angles, and in this case that would be the obtuse angles, we would substitute the fact that x is 32.5 into one of those equations. I've chosen the first one because it's all positive and that's normally easier. And if you put that into your calculator, you'll find that 3 times 32.5 plus 18 is 115.5 degrees. Here are 3 similar questions. The first one is another one where you've got 2 obtuse angles on a diagram showing vertically opposite angles. The second and third question focus on the side lengths of 2 shapes. Give it a go, see what you can come up with before checking for the answers. Okay, so on the first one, I made this for my equation, using the fact that those 2 angles must be equal, and then solved through to get that x is 9. And that's all it wanted for the red question. The orange question, the reason why you can say that is because the opposite sides of a rectangle are equal, they have the same length. And if you make those 2 equal to each other and solve, you should get that x is 7. On the isosceles triangle, the 2 marked sides are equal because an isosceles triangle has 2 sides that are equal. You can then use those 2, 4x plus 15, equal to 33 minus 2x. If you solve that, you'll find that x is 3, and then substitute x is 3 back into all 3 expressions to get a perimeter of 69. It doesn't give units. Okay, one final check. Have a go at these 3 questions, see if you get the right answers. When you unpause it, you'll get them answers to show. Okay, answers are here. X is 6, 5 and 8. Okay, before you shut down for the day, please make sure that you submit your work to your teacher. Well done.